Hello, good afternoon. Today I'm going to be doing my presentation on Umar Khayyam. I believe that's how you pronounce his name. I looked it up and I'm pretty sure that's it. Hopefully I won't sound offensive with pronouncing some of the names of these people that I'm going to present today. So it's a little bit of background about the person I researched today. So he was born on May 18th on 1131. He was born around the medieval Eastern Age, medieval Middle Eastern Age. I believe that was also during the Islam, the Golden Age of Islam, something like that. I could be wrong. His full name is Abu Fat Umar Ibrahim Khayyam. Hopefully I didn't butcher any of that right now. He lived in the city of Nishapur. It's around the area where present-day Iran and Afghanistan is located in. So he has a big historical significance in that area with the accomplishments that I'm about to list out today. So in his early career, he was there was a shift in dynasties around this area or around this time period. So the previous dynasty was overtaken by the current group that will be later ruled by what's his name? Malik Shah. Well, this is the son of the guy who conquered the province of Khorasan. I could be saying that wrong, but yeah. So Malik Shah, he was ruling the dynasty that ruled around the time of Khayyam was very heavily like militaristic in a way. They prioritized more on military than intellectual ability. So what comes next is actually pretty significant and rare in this time period. So Malik Shah invited Karam and a pupil of his mentor. The mentor's name is called Mawafaq, I believe that's how you pronounce it. And the reason why Malik Shah invited Khayyam and the other pupil is it was well known around the time that the pupils of Mawafaq bestowed great fortune and wealth whenever taught by this individual. So Malik Shah decided to partner up with these two pupils and basically share the wealth whenever that is bestowed upon them. The other guy he got wealth, but it kind of didn't work out. He became like the old man in the mountains, which means like he became an assassin in a sense, which is kind of crazy. But Khayyam, he kind of, well, he wasn't like, he was chill at the very end. He just wanted just a livable wage so he can study science and mathematics while under the rule of this current dynasty. So some of the early accomplishments of Khayyam is that he actually created a calendar that current day Iran and Afghanistan still use to this day. And this calendar is more accurate than the Gregorian calendar, which is kind of interesting. From what I can see, like the calendar would create a new calendar. The calendar estimate or measured the solar year to be 365.24 days. Well, I believe the Gregorian calendar is similar to 365 days, 0.24, but then I believe it's 2-0. So I guess like the Gregorian calendar is not as close as an estimate, because there was when I researched this was a bigger string of numbers, and then the Gregorian calendar had a smaller string of decimals. But yeah, it was introduced in 1079. Another fun fact about the Gregorian calendar that will be introduced several more centuries later, so which is pretty interesting. So besides Khayyam accomplishing in the astronomical field, you could say, he was also a very famous poet and philosopher. That's the word. So he wrote a book called The Rubaiyat of Omar Khayyam. So, and I'm pretty sure it's just like, he just wrote a lot about what he was thinking. He was very inspired by the Greeks, therefore that's why he took up this type of form of thinking. He is very heavily inspired by the Greeks, even like in the math. That's why later on when I bring up his mathematical accomplishments, he focused on the works of the Greeks on the squares, the square root, not the square solutions, and then he will work on the cubic. But back to this. Like I said, he was a very famous poet and philosopher. On his poetry, he would eventually become very well known, and he would gain fame after his death, of course, on his poems in the Western world. Whenever those are translated by what's his name, by Edward Fitzgerald, and I believe it'll be in the 1500s. But yeah, like I said, yeah, he has some mathematical significance. So in 1070, he would write the book of Treatise on Demonstration of Problems of Algebra. So it's just his work that he did during algebra, or while he was studying mathematics. And one of the big things that he was able to find is find positive roots for several cubic equations by intersecting conic sections. He found 14 cases of his method working. And he kind of delved into the Euclidean geometry. He was trying to prove the parallel, what's it called? The parallel postulate. So, and really just trying to solve or trying to prove for that postulate, he was actually able to argue, or he was able to create more evidence towards non-Euclidean geometry. So I left a blank space here as to show the work, or just show a premise of what his proof was whenever he was trying to find the cubic solutions. So, like I said, this is probably a very simplified version of what he did. But let's say we have, a graph, and then we have a parabola, this going this way, and then we have a semicircle right here. Let's have this vertex be B, the end right here be A, C. Let's have A and B be represented by B. Let's be BC represented by C. And then we also got this intersection D. So what Khayyam discovered is that this intersection of these two functions, you could say, was a solution to his cubic equations. While this one shows one intersection, so I believe he argued for or he figured out a way to get two solutions, but really he didn't really find a way to get three solutions for the cubic equations. And so this is how to you find it geometrically, but what if you want to have an algebraic description of it? So that's why I kind of wrote up a little proof to have a clear explanation of it. So hopefully I can get all this. So let the functions of parabola, and let's define it as x squared equals by, and a semicircle represented by y squared equals x parentheses circle minus x, b on graph. So, like I said, parabola right here will be represented by x squared equals by, and this parabola, y squared equals c minus x. All right. And then we'll say, suppose the point D is written as x0, y0, and point B, suppose point D is the intersection of the two functions, as the graph shows. Then x squared equals by, or x0 squared equals by 0. And if you multiply this, or if you raise it to the power of 2, you get x to the 4th equals b squared y0 squared. Similarly, we're kind of replacing the variables here, so we're going to have to replace the variables for the semicircle function as well. So the semicircle function will now be y0 equals x0 c minus x0. Thus, we can make all of this equal to each other. This function equal to this. Oh wait, I meant to put y squared or y0 squared, because we can now connect these two with x to the 4th equal b squared y squared, and we can replace this y squared with this function. So x to the 4th is now b squared x0 c minus x0. From here on out, we can also cancel out an x on both sides. So now we've got hence, hence x to the 3rd, or x cubed, is equal to b squared c minus x, which can be distributed or simplified down to x cubed is equal to b squared c minus b squared x0, which, if we move all the x's to one side, it's equal to x cubed 0 plus b squared x0 equals b squared c. And this is the function, or this is the solution that Khayyam was able to figure out by doing all this. So thus, x0 satisfies x squared b plus b squared x equals bc. So this whole proof really is just showing that the original equation that Khayyam was able to find out, this one, x squared b plus, or x cubed b plus b squared x equals bc, is able to be solved by this this graph right here with the two functions. So let me erase this and continue on with the presentation. All right, let's move on. So some limitations about this cubic solution that he came up with is that he was able to find one solution and two solutions with this method, but he really wasn't able to discover there are like 3 solutions with this form. But yeah, and also like for most of like math history, you could say, nobody really took into account negative numbers, so he kind of disregarded that, and he also disregarded positive roots. And at first he concluded that there's no algebraic solution of the cubic, but it would later be proven false, obviously, later on down the line. To end off Khayyam's story, like in his life, really not the presentation. The guy who Malik Shah, who was like really chill with Khayyam, would later die. And will be later taken on, and then his son will take over, and then he would put more emphasis on military power. So Malik Shah's like emphasis on intellectual like capabilities, or in a way, he kind of put that to the side and focused more on military. So Khayyam would actually be shunned from the society he grew up with, you could say, and he would be viewed as weak and maybe useless under the rule of Malik Shah's son. So and due to that, like everybody looking down on his work wouldn't be distributed that much outside of the dynasty until like a bunch of crusades would happen on the dynasty, or in the province as well, releasing his knowledge to the Western world and giving the Western world a leg up in a way. But yeah, like I said, he would really be influenced. He would have more of an influence in his literature, you could say, because he was, like I said, he was a poet. So his poetry would later be translated by Fitzgerald over here, and like I said before, he would gain a lot of fame in Europe through his poems. Khayyam's calendar, like I said, is still used to this day and is more accurate to the Gregorian calendar. So only two countries I can see still follow it. Like I said before, Iran and Afghanistan. And it's called the Jalali calendar. Another thing I could be pronouncing wrong. And all these I've stated before. Khayyam was able to put more effort into non-Euclidean geometry whenever trying to solve the postulate. And his work would be, his mathematical would be founded and translated and be a help for the Western world and make way for the intellectual renewal of the West. Summary, but yeah, Omar Khayyam was able to play a big part in the 11th century in the development of geometry and cubic equations. While skillful in mathematics, he showed in his knowledge in astronomy, philosophy, and poetry, especially poetry. And his contributions to mathematics led to developments in several fields like algebra, geometry, non-Euclidean geometry, and much more. And yeah, these are my sources, and I hope my presentation went well.